Hello, welcome back, and this is our last lesson in the radical unit. We're still going with the system of the whiteboard. I know there's a glare and it's a bit tilted, but like I said, in terms of technical issues, this is the best that we have at the moment. So we're all feeling it the same way. I'm sure you've experienced some technical difficulties all along the way, but like I said, this is all a new process that we'll get through together. Okay, so our last topic is radical equations. So a little bit different than what we've been doing. We've been adding, subtracting, multiplying, dividing, combining, like terms simplifying. None of that there. This is more algebraic solving. So we're looking at radical equations. So right now we've been talking about radical expressions. This is the first time we're now looking at a radical equation. So by definition, a radical equation just means that you have a variable under a radical sign. So our example would be the square root of x plus 1 equals 0. So we'll start with a real simple, easy one just to go through our rules. So to solve, step number 1, we have to state our restrictions. I did mention that in a previous lesson. I'll talk about it a little bit more. The key thing that we need to learn now, and it comes up a lot in grade 12, you cannot take the square root of a negative. So that line you do need to remember, and that comes up quite a bit in grade 12 pre-cal. So because we can't take the square root of a negative, we have to state our restrictions up front. So let's look at this example, the square root of x plus 1. Anything that is under the radical sign has to be greater than or equal 0. That's just another way to say you can't take the square root of a negative. X might be negative, but the entire thing can't be negative. You cannot take the square root of a negative number, so we have to state a restriction. So whatever's under the radical sign has to be positive. That's all that says. And then you should know how to work with inequalities from previous math years. So that means x has to be greater than or equal to -1. You kind of treat it like an equal sign, but like I said, you should know that coming into grade 11 pre-cal. That's going back quite a few years in math about working with inequalities. So step number 1, state the restrictions. Step number 2, you're going to isolate the radical. Step number 3, you're going to solve. And then number 4, check. The check part, there's going to be some new language that comes up. So a lot of the basic skills you have already. Just the new part is we're going to talk about stating our restrictions and how and what you do when you check. But all the rest in between are just your basic math algebra solving for variables. Okay. So we're going to try, that's right, before we go to our example, there's another statement I have in your notes. So the notes, by convention, we always take the true root or the principal root. What does that statement mean? Well, if I give you the question, x squared equals 4, what's the solution? There's two answers. X can be plus or minus 2. So if we start with that statement, there's two answers. But if we start with the reverse, what's the square root of 4? Then we have only one answer. It's just 2. It's not plus or minus 2, it's just positive. That's because when you take the square root, you just take the positive root. That doesn't quite make sense. Just bear with me, it'll come up in examples, but that's why when we're solving, the square root of a radical has to always be positive. Okay, let's put all the pieces together and try some examples. So our first example, the instructions now say solve because we're now dealing with equations, not expressions. So the square root of x equals 5. You probably don't need any steps. I think you can tell right away. We look, the answer is 25. Hopefully we know the square root of 25 is 5. So that's easy. Why would we bother doing all these steps? Well, let's just practice the 4 steps on a simple one. So when it gets a little bit harder, we're confident and can apply those skills to harder ones where we can't just look at it and get the answer right away. So step number 1, state our restriction. Well, that's pretty easy. X has to be greater than or equal to 0. You cannot take the square root of a negative number. So that's pretty easy. Then step number 2, isolate the radical. Well, that's easy. It's already been isolated. Then the next step, we get rid of the radical. How do you get rid of the radical? I think we know to get rid of a radical, you square both sides. We've done some work with that, I think, in the past. So the square root, or 5 squared, is 25. The square root of x squared is just x. And then we're done. We've done step 3, we've solved, and now we're going to check. So when we check it back into the original. And yes, that works, so we keep our solution. Now be careful, sometimes students do the check and they'll say their solution's 5. The solution isn't 5, the solution is x equals 25. Okay, so those are the steps. You state your restriction, you isolate the radical, you square both sides to get rid of it, you solve, and then you check. Like I said, we didn't need any of those steps. We could have seen right away it was already 25, but those are the basic steps when we go ahead. Okay, example number 2. So now you can see why we learned those steps. What's the answer to x right here? It's not so easy. We can't just look at it and get the answer like we did for example 1. Well, maybe some of you can, but most of the world cannot just look at the answer and get the value to x. So now this is where we apply our steps. So step number 1, state the restriction. So this is where the restriction comes from. Whatever is under the radical sign has to be positive. You cannot take the square root of a negative. So again, just rearranging. Again, you don't have to show all these steps. Your x value has to be greater than or equal to -2. That's the restriction. We'll introduce that now, but that's going to be a key concept in grade 12 pre-cal. In grade 12 pre-cal, we're going to be graphing radical graphs, and that's where knowing the restrictions is going to be really key to get the right domain when you graph those. So we introduce this now to make grade 12 a little bit easier for you. Okay, step 1, we've stated our restriction. Then we isolate the radical. I might have forgot to write that step on my first slide, but I have it correct in my notes, so follow along in the notes. So step 1, state your restriction. Step 2, isolate the radical. Well, the radical is not isolated yet, but that's pretty easy to do. Just subtract both sides by 1, and then you get your solution. Watch your communication error that your radical sign goes all the way. Okay, step 1, we stated our restriction. Step 2, we isolated our radical. Now step 3, we solve. To solve, you square root, or you square, not square root, you square both sides. The left-hand side is easy. The square root of 4x plus 8 squared is just 4x plus 8. But the right-hand side, we have lots of concept errors. Remember, this is going back to grade 10 math. X minus 1 squared is x minus 1 times x minus 1. So you know how to multiply polynomials. We spent a long time in grade 10 math doing that. So if you do it correctly, you should get x squared minus 2x plus 1. Now we are back to Unit 2 quadratic equations. So this is the good part about math. We just keep redoing everything we've learned. There's nothing new from here on in this question. The only new step was the restriction. This is now Unit 2 quadratic equations. So it's a good time to practice what we learned when we were still here in class, when we were learning about quadratic equations. Bring everything over to one side. Again, if you combine like terms and have everything correctly, you should get x squared minus 6x minus 7 equals 0. How do we solve? Well, we had a whole month-long unit on this. We can factor, use the quadratic formula, we can graph it, we can complete the squares. Remember that unit? There's a reason why we learned how to solve quadratic equations. It keeps coming up grade 11 and grade 12. So yes, you'll be solving many, many more quadratic equations in your lifetime. I will choose to solve it by factoring, because I think that's the easiest. So the factored form is x minus 7, x plus 1. Don't forget that equals 0. You don't want an E2 communication error. So when we solve, we have two solutions, x equals 7 and x equals minus 1. There was a purpose for that whole quadratic equation unit. We will use it in many different situations to solve. Okay, so that was lengthy. Step 1, we stated the radical, or we stated the restriction. Step 2, we isolated the radical. Step 3, we solved. Now we have to check, do both of those count? So these are long and they're tedious, but like I said, it's not hard. From here on, after the restriction, there's nothing new. So when you check the restriction, you go back to the original equation before we did anything to it. So we had two solutions. We do have to check both. So to check them, oh, and instead of an equal sign, I'm going to make a T-chart. We will be using T-charts in grade 12, so if we use them properly in grade 11, that will make grade 12 better. We don't put an equal sign because we actually don't know if they're equal. So if we put an equal sign and they end up not being equal, that's a communication borderline concept error. So we use a T-chart in place of the equal sign because we don't know if they're equal. We're going to test that. So we replace all the x's with 7, and then the rest, this is just, oh, probably grade 7-8 math. We get, oh, and again, I'm getting lots of communication errors here. We have 28 plus 8, which is 36. Again, the square root of 36, just plus 6, not negative 6. Oh, and they are equal. So yes, that solution works. We can keep x equals 7. So it's a solution, we tested it, it worked. Let's try the same thing on the right-hand side. Again, I'm going to use a t-chart instead of an equal sign. Same thing, we replace all of our x's with -1 now. Again, this is the hopefully easy math. We have -4 plus 8. So that gives us 4. Square root of 4 is 2. Okay, now we look. 3 and -1 don't equal each other. So that's why I didn't have that equal sign. I used the t-chart. So x equals 1 was a solution we had, but it doesn't work. So how do we show that we don't keep it? That's all you have to do, cross it out. So you do have to show that you had 2 answers. You do check them. If it works, that's fine. If it doesn't, cross it out. We have a special name for this value. That is called extraneous. That is an extraneous root. And I don't think I explained it in your notes. I will talk about it quite a bit. What is an extraneous root? An extraneous is a root, it's a solution we get. So we had 2 solutions, x equals 7 and -1. There's 2 solutions, but when we check them out, not both of them worked. So the one that doesn't work is extraneous. It does not satisfy the original equation. So just because we had 2 solutions, when we solved, not both of them worked. We kept the x equals 7. The x equals -1 was called extraneous. So you always have to check, and then if you reject it, like I said, how do you reject? You just put a line through it. That comes up a lot in grade 12 math. We're going to be solving lots of quadratic equations, lots of testing for extraneous roots in grade 12. So there you go, your first exposure to extraneous roots. Okay, one more example. So 4 plus root x plus 8 equals 3. Step 1, the restriction. You cannot take the square root of a negative number. So anything that's under the radical has to be positive. So our restriction, x has to be greater than or equal to -8. That's step 1. We stated our restriction. Step 2, we have to isolate our radical. Now the radical, it's not isolated, but to do so you would have 3 minus 4, and that gives us -1. Well, I can stop right here. We said the square root, we only take the principal or true root. I'll explain that statement now. That means the square root has to equal a positive number. This statement can never be true. This would not be a principal or true